Hello, welcome to Jet Mathematics. I remain your host, Milton Ebiwarijan. We are still on the series of simultaneous equation. Today we are looking at solving three equations simultaneously with three unknowns. Quickly, we have an example on the board. It says solve x minus y plus 3z equals to 5, x plus y plus 6z equals to 12, 3x minus 2y plus 2z equals to 10. So we'll call this equation 1, we'll call this equation 2, call this equation 3. Okay, so we are solving this analytically. Maybe in subsequent videos we'll use maybe the Cramer's rule or determinant method to solve this problem. But now we'll just go straight. First, we're going to make x the subject matter from equation 1. So from equation 1, we'll make x the subject matter. So from equation 1, s is equal to 5 plus y minus 3z. You can call this equation 4. Okay, so from 1, we have made s the subject matter. What we need to do is to substitute this expression for x into equation 2 and equation 3. This will reduce equation 2 and equation 3 into two unknowns. So we'll do that. Substitute x into 2 and 3. So we are substituting the value of x, the expression for x here, into 2 and 3. So bringing this into 2, for 2, we have that if we put x here, we have 5 plus y minus 3z, then plus y plus 6z equals to 12. So simplifying this, we are going to get y plus y is 2y, then minus 3z plus 6z is plus 3z, okay, equals to, this is 12. Then when 5 crosses to this side, becomes minus 5. So 12 minus 5 gives us 7. So we'll call this new equation equation 5. Okay. Then substituting x again from here into 3, we'll have okay, 3x. Remember our x is this, 5 plus y minus 3z. Then we have minus 2y plus 2z equals to 10. So we'll simplify this, we'll expand this, we'll have 15. Then here we'll have 3 times this gives us 3y. Then 3 times this gives us minus 9z. Then we'll have minus 2y. Then we'll have plus 2z equals to 10. So finally we have 3y minus 2y gives us y. Then minus 9z plus 2z gives us minus 7z minus 7z. Then here we have 10. Taking 15 this way becomes 10 minus 15. And 10 minus 15 is 10 minus 15 is minus 5. So we'll call this equation equation 6 now. Okay. So the next thing we need to do is to solve equation 6 and 5 simultaneously. If you observe that these equations have been reduced to two variables, y and z, so we can solve them simultaneously. So we have for 5 is 2y plus 3z equals to 7. And then for 6 we have y minus 7z equals to minus 5. So we can solve these two simultaneously. I'm going to use the elimination method, or we can even use the substitution method as we have discussed in our previous videos. So okay, let's use the substitution method. Here we have from 6 we'll say that y is equals to minus 5 plus 7z. That is from 6. We'll make y the subject matter from 6. We have minus y, then this goes here, becomes plus 7z. Now we're going to substitute this y into 5. So if we do that into 5 becomes 2, and our y, which is not this, is minus 5 plus 7z. Then here is plus 3z. Okay, then equals to 7. Pretty easy, right? Let's continue. So expanding this, you have 2 times this is minus 10, then 2 times this is plus 14z, and then plus 3z equals to 7. Alright, then next you sum up. So 14z plus 3z is 17z equals to taking minus 10 this way becomes plus 10. So we have 7 minus 10 goes there, plus 10. So we have 7 plus 10, that gives us, okay, let's just say 17. That gives us 17. So z is 17 divided by 17 from, here we'll divide both sides by 17. So z is equal to 1. Pretty easy. We have gotten one of our variable, and that is z. With this we can get the rest. Very easy. Let's call this our equation 7. Then we can easily get our results. Let's call this equation 7. Okay, so we can get our results for x and y very easy. So to do that, we say substitute z equals to what now? 1 into equation 7. we do that at equation 7, where is it? Yeah. So we get y is equals to minus 5 plus 7z. So y is equals to minus 5 plus 7, as z is 1. So this was y equals to minus 5 plus 7. That's y equals to 2. So we've gotten y, we've gotten z. So we are going to substitute z equals to 1, y equals to 2 into, we called this equation for s the other time equation 4. So I'm going to substitute that into equation 4. So that will help us get x. So recall equation 4, x is equal to 5 plus y minus 3z. So s is equals to 5 plus our y is 2 minus 3, our z is 1. Okay, so this gives us x equal to 5 plus 2 minus 3. So s is equals to 5 plus 2 is 7, 7 minus 3 is 4. Wow, we've been able to get our three variables. Therefore, we conclude by saying x is equals to 4, y is equal to 2, and z is equal to 1. Alright, that's the end of this problem. Like I said, we can use other methods like the matrix method and the determinant method, otherwise called the Cramer's rule, to also solve this problem. There are several methods. Maybe in our subsequent videos we'll adopt some of these methods to solve three unknowns with three equations. Alright, see you in our next video. Bye.